Here this is R2 and we have R1 and R. So this is a diagram. Now we write down the general form for the Gauss law. So this is the Gauss law. We start from A. We are asked to determine the electric field in the range between this R1 and 0. So from this Gauss law, we get this E A equals to Q enclosed over the epsilon. So E will equals to Q enclosed over A epsilon naught. Now in this case, you see the range here. This R is smaller than R1. That means this is somewhere here. They are not able to enclose the sigma 1. They are not going to enclose any charge. So Q enclosed will equals to 0. The E field will also be equals to 0 in this given region. Now we proceed to B. B, we have this R between R2 and R1. So between R2 and R1 is the region somewhere here. You can see here in this case this sigma. If this have a sigma 1, that means we have a charge get enclosed by this surface we choose. So we use the same thing. E equals to Q enclosed over A epsilon naught. And now this case we know the sigma 1 is defined by the charge density. So let's say they have a charge Q. In this case, which is the charge enclosed by this the surface we choose. So we can write this is a charge enclosed over the area. In this case, this area is the area of this a spherical shell. That means this is a 4 pi r1 square. So from here we know the charge enclosed is equals to the sigma of 4 pi r1 square. This is equals this one should be a sigma 1. Sigma 1 4 pi r1 square over the A. In this case, A we also choose the spherical shape and with the radius r, so we get this is a 4 pi r square epsilon naught. So this 4 pi can be cancelled out. Finally, we get a sigma 1 r1 square over epsilon naught r square. Now we go to this C. In C, this R is greater than R2. That means this will enclose all the charge in this diagram here. This is the case C. This is case B, and inside one is the case A. Now Now this Q enclosed will equals to the sigma 1 multiplied with 4 pi r1 square. This is for the internal spherical shell, the charge on the internal spherical shell. And we have the addition of this the charge on the outer spherical shell. So this is given by sigma 2 4 pi r2 square, and the whole thing is over the area we choose. The area we choose is 4 pi r square, and of course this epsilon naught are still here. You can see this 4 pi is still get cancelled out. So finally we get a sigma 1 r1 square plus sigma 2 r2 square over this epsilon naught r square. This is the answer for C. Now let's see D. Under what condition this E will be 0 for R is bigger than R2. E is equals to 0. At this R at this R is bigger than R2, we will get we must have this Q enclosed equals to 0, right? So in this case, we take a look back into the case C because this is correspond to the case C. So we can write this way: sigma 1 r1 square plus sigma 2 r2 square equals to 0, and this sigma 1 r1 square equals to minus sigma 2 r2 square. You can see here that this have an extra negative here. That means there must be the opposite in the polarity. So the shell must have opposite charges. So this E field equals to 0. Say no net charge in the internal shell